And joining us now live is Arunabha Ghosh, CEO and founder, I should say, of the Council of Energy, Environment and Water. It's delightful to see you there. We've been trying to make a connection with you for a while. I must tell you that the Council is one of Asia's leading research institutions, and Dr. Ghosh has advised the Indian and French governments, also the UN Secretary General, on various aspects of delivering green economic development. And we have asked him today to speak to us about the challenges of a rapid, large-scale deployment of renewable energies for a fast-growing developing country like India. Over to you, Dr. Ghosh.
Thank you, Nisha. Thank you very much. And thank you to NTNU for inviting me to this important discussion. In the little time that I have, I want to talk to you about, first of all, how large the transition it is that India is undertaking. And then I'm going to outline to you three main challenges that are involved with the very large scale up of renewables that we are trying to pursue. Let me see if this works. Yes. I run the Council on Energy, Environment and Water. We are ranked amongst the 20 best climate think tanks in the world. But from that slide, what you can see is, for us, the energy transition that India is going through is part of a system level transformation, but which also impacts quality of life issues, but requires the enablers of finance and technology and resilience to work and scale up. So it's with that background in mind that I wanted to first illustrate to you the size of India's energy transition, at least from the renewable energy story alone. That graphic shows you how rapidly renewables have been deployed in India. In 2010, when CEW was set up, was also when the National Solar Mission began in India. At that time, India had less than 20 megawatts of solar. We now have over 75,000 megawatts of solar and over 189,000 megawatts of non-fossil electricity capacity. Well, that's not enough. India is aiming to deploy 500,000 megawatts of non-fossil electricity capacity by the end of this decade, which basically means that the country that has already become the fourth largest renewables market in the world by deployed capacity, fourth largest in wind, fourth largest in solar, nearly 300% increase in RE capacity in the last 7-8 years, is going to see another 3x increase in renewables over the coming remainder of this decade. Now, that's what is happening for the world's fourth largest electricity market. What kind of challenges does it pose? Now, often when we talk about the deployment of renewables, especially from an emerging market or developing countries perspective, some of the basic challenges that often emerge is about money, the resources, the financing. But I am not going to spend time on that right now, not because it's unimportant. It's very important, but I can get into that if there is a further discussion. I want to talk to you about some other structural challenges that we've got to keep in mind. Because as we go from a low share of renewables to now a very large market, which is going to go 3x, remember even that 3x at 500 gigawatts of non-fossil electricity capacity still pales in comparison with what our net zero model suggests, that we'll have 5,600 gigawatts of solar for net zero, 1,700 gigawatts of wind for net zero. Now, this scale has not even been imagined before anywhere else. So what kind of challenges are we faced with them? The number one is, how do we integrate such large volumes of renewables into the grid? And that has implications for the grid, it has implications for energy storage, and it has implications for power markets. Let me just illustrate that with four simple graphics. And these come from the load curves. From the top left is the most recent data we have, literally from 2 days ago, 10th of March. Top right is from a typical summer day in June last year. Bottom left is from September last year when we had the maximum peak demand and then a typical day in the winter. Now, 2 days ago, in the peak, renewable generation accounted for 25% of total generation, even though we are at 44% of total capacity. Uh, in June last year, in the peak, renewables accounted for 31% of total generation. In September, the highest peak load of the year, renewables accounted for 18% of generation. And in winter, it accounted for 22%. What that's basically telling you is that there is already a very large share of renewables in the Indian electricity mix, which often is thought of as something that is heavily fossil fuel dependent. It is, but at the margin, renewables is winning by capacity, but at the margin on a daily basis also, there is a non-trivial share. But what that means is we also have to ensure that we build out the grid, we invest in the storage, but we also invest in the demand side on power markets that then optimize for how the load curve is used through the day to optimize for more and more share of renewables. That's problem set number one. Very quickly, when we are scaling 3x renewables over this decade and then even beyond, we also have to account for the fact that supply chains in clean tech are heavily concentrated. Um, the numbers we calculated for the G20 show that over the past decade, while the number of countries that had concentrated sources of imports for wind remained similar, for solar, it jumped up from 38 to 71 countries, and for lithium-ion batteries, it jumped up from 19 to 49. This level of concentration in clean tech supply markets creates an energy security problem for the fuels of the future, because the energy security architecture we currently have is oriented about the fuels of the past. So how do we ensure that when the solar panels are needed, or when the batteries are needed, or when the critical minerals are needed, they will be available to ensure that the deployment of this capacity happens at scale, but also at the speed that is necessary? This is no longer a margin play. This is a global governance problem, and large emerging economies that are going to deploy this large infrastructure need that security. The last thing I want to say is that we often think about the energy transition as something far removed, either in geography or in time scales. But unless we bring the energy transition closer to people, we will not get the buy-in from the communities, from the small businesses to invest in these new technologies. I'm going to illustrate that with one example. Out here is a very rudimentary brass manufacturing facility which uses coal to melt brass at 1200 degrees Celsius. Now, why have I highlighted this? Because micro, small, medium enterprises serve as the backbone of the industrial structure, not just in India, but in most developing economies. If we cannot figure out a way to bring the energy transition closer to such enterprises, we are not going to have not just the electricity system change, but the industrial system change. So what we did with my colleagues at CW and with this brass cluster is replaced coal with natural gas and reduced emissions by 55% to melt brass for the first time in India. And I'm holding a block of green brass, melting brass for the first time at 1200 Celsius without coal. Now, gas is not renewables, but at the same time, it gives you a sense of what is needed. But when you scale this up, the potential for using distributed clean energy, renewable energy in just rural India alone for livelihoods is a $50 billion market. For sub-Saharan Africa, just for solar irrigation, it's a $12 billion market. But right now, the finance, the investments, the business models, the market linkages, the support to enterprise, entrepreneur, and the ecosystem doesn't exist. So when we think about heavy injection of renewables, it's not just the flat energy curves that we see in the global north. We have to account for the upward sloping energy demand curves in the global south and think about the supply chain challenges, think about the grid integration and battery challenges, and then think about the financing for the small business challenges. None of these challenges is something that is insurmountable. But we now have to start thinking about the energy transition, not just from a macro planetary perspective, but a micro household and enterprise perspective. And that's what will make this story come alive. Thank you.